We have talked about equations and functions. We also learned how to graph equations or functions. In this video, we're going to talk about graph transformations, and we're going to practice how to graph a certain function using transformations. Although we have graphing calculators or computer softwares nowadays to help us graph functions, it would still be very useful if we know all these graph transformations because they can help us understand functions better. So first, we're going to look at some basic functions. The very common functions we have, the first one, f of x equals x squared, which is a quadratic function. We can look at what the graph looks like. So we're going to do the same thing we did before. And in order to graph this function, we have to have points in the xy coordinate system. So first, let's pick a few numbers for x and determine what the y values. So we can start with 0, replace x with 0, and 0 squared. And by the way, f of x, we often use y, and it's to represent that. So y would be equal to 0, because 0 squared is still equal to 0. And then we can pick 1 for x, 1 squared is still going to be 1. And we can pick 2 for x, and 2 squared will be equal to 4. And next, we can pick some negative values. For example, we can pick -1 for x. -1 squared is still going to be 1. And notice negative times negative will still be positive. And similarly, -2 squared would be positive 4. And we can pick more numbers, but I think that should be enough for us to see what the graph looks like. So let's look at use those values. The first one corresponds to the first pair corresponds to the point 0, 0, which is exactly our origin. And the second pair corresponds to a point 1 and 1. So x is 1, y is also equal to 1. The third pair is x equals to 2. That's x-axis, y-axis, and x equals 2, then y equals 4. Let's count 1, 2, 3, and 4. So I got a point up there. And for negative values, for x is -1, we have y 1, and x is -2, we have also y equal to 4. So now we have these 5 points, and we can join them to get a curve. And if you're not able to see why this is a curve, we could pick more points to see. For example, you can pick 0.5 or 1.5 and so on, and to sketch the graph. Sorry, this point is a little off. Okay, well, my graph is not does not look very good, but if you use a graphing calculator or graph softwares, you can see this looks like a what we call a parabola. Okay, similarly, we can do the same thing with the second one. Pick a value for x, so square root of 0 is going to be 0. And notice for square root, again, the only chapter we would talk about imaginary numbers will be the quadratic formula chapter. And so for the functions here, we only talk about real numbers. We're not going to talk about imaginary numbers. So that's, and we know square root of -1 is not going to be real. So we consider it as undefined. All right, so we pick positive values for x. 1, square root of 1 will be 1. If I pick 2, I will get square root of 2, which is not really a very easy number to plot. So I'm going to pick a perfect square, say 4, to get square root 4, which equals 2. And similarly, I can pick 9. Square root of 9 will be 3, and 16 will be 4. I think with these points, that should be enough. So we have 0, 0, 1, 1, and 1, 2, 3, 4, and would be 2 right here. So we plot those points, and another one would be 9, so it's going to be a little further to the right. So we're going to join these points, and you can sort of see what the pattern is. Okay. All right. So that's, we can kind of remember what the graph looks like. So for example, for the x square, the parabola is always above x-axis, and the square root of it's only in the first quadrant, because x value is positive, negative is also positive except the origin there. So now we can look at the next one, x to the third. We can do a similar thing to pick values. So here I'm going to work on this a little quick. This time the exponent is third, so which means if you pick a positive number, and you're going to get positive. But if you pick a negative, you're going to get negative, because -1 times -1 times -1 3 times, that's going to give us a -1. And -2 will give us -8. So this time we are going to, I'm sorry, that should be 0. So x pick 0, y should be 0. X is 1, y is also equal to 1. But when we pick -1, we notice we get also a -1. So you can kind of see it's symmetric about the origin right here. So x, if we pick 2, we get 8, which is way up there. 1, 2, 3, 4, 5, 6, 7, 8. So we're going to get a point up there. And for -2, we're going to get a point way down here. If we join those points, again, because we only have a few points, might be difficult for us to sketch the graph. If it's necessary, you can pick more points using your calculators, like say 0.5, 1.5, and so on. All right, so we're going to just get a general idea what the graph looks like. All right, and the next one we have 1 over x. So if you're going to take calculus class, these are the very basic functions we're going to use, very common, the graphs we're going to study in that class. Okay, so notice that if I pick 0, it's going to be undefined, because 1 over 0 is undefined. So that means we're not going to have anything right for x equal to 0. Or in other words, the graph is not going to intersect x-axis or y-axis. So we're going to pick a few numbers here. Usually when we pick numbers, try to make it diverse. Pick some positive ones and pick some negative ones. Okay, so let's see. When I pick 1, I got 1. But when I pick 2, I actually got 1/2. And you might need to pick more, like say 3 would give us 1/3. But if I pick 1/2, actually I'm going to get, because the reciprocal 1/2 is going to be 2. Okay, so I'm going to get a point there. So I didn't list all of them here, but you can continue to make our list longer. Okay. So I got these many points for positive ones. You can sort of see the pattern of the graph. So the graph looks like this. And notice it doesn't touch y-axis or x-axis. So it's going to go up forever, because you can keep picking the fractions like 1, 1/3 or 1/4. Okay, similarly, if I pick negatives, I'm going to get a -1 for -1. But -1/2 will become a -2, and -2 will become -1/2. So that's going to give us a graph like this. Okay, all right. So these are some of the basic functions we are going to use, and to look at how we use these graphs to do transformation. So the first transformation we're going to talk about these transformations. First of all is translation, and then reflection, and stretching and shrinking. So first let's look at translation. Now there are two translations. One of them is vertical, the other is horizontal. So we can, if we start with this function, the basic function square root of x, if you remember, the graph looks like this. It's only in the first quadrant. So I'm going to draw the graphs for square root of x, which we just did. Okay, so this is the function f of x equals square root of x. And if we add a 2 to it, see what's going to happen. And notice that whenever any y value, because when we add a value, we're adding a value to the y value. So previously, that table we have here. So if I make another one so this y is square root of x. if I can add another column here for the function y equals square root of x plus 2, and every value I got for this function y, I just need to add 2 to it. So I'm going to get 2 plus 0 is 2. 2 plus 1 is 3. 2 plus 2 is 4. 2 plus 3 is 5. So that's going to notice that every y value we got previously, like a 0, 1, and a 2, next one will be 3. All of them will be added of 2 to it. So this pointer will be shifted. This pointer will be moved up 2 units. Because this point 0 will be moved to 2, and this point 1 will move to add 2 to 2, 3, and this 4. This 2 won't, because the y coordinate is 4 now. So again, we're going to move it up. Okay, to 4. So the graph looks like that. My graph probably is not very scaled, but you can see the whole graph is moved up 2 units. And similarly, if we have square root, so what I just did is for the function of square root of x plus 2, but if I shifted it down to square root of x minus 2, and every y value that I got, I'm going to have to subtract this y value I got, because this is this column is for the value of square root of x. I'm going to subtract 2 from it. That's going to give me -2, -1, and a 0. So in that way, originally we got a 0, subtract 2, that goes down to -2. And this 1 goes down to -1, and this 1 goes down to 0. So that gives us a curve that looks like this. And as you can see, this one is y equals square root of x, and this one is y equals square root of x plus 2, and this one is y equal to square root of x minus 2. So how the graph moves, whenever you add a number to it, you're going to have to move the graph up from the values you can see y. Because when you add a number to the y values you already have, say 1 or 2, you're going to increase every y value by 2 units. So that's why the graph is shifted up. And if you subtract 2, it's going to be shifted down. So up 2 units or down 2 units. So this is the first transformation, which is called translation. All right, now the next one we're going to look at is called reflections. So if we have, actually we also have, this one is, I'm going to talk about horizontal translation. Okay, so this time we start with the function x squared, which we know. We can go back to the graph we already have, and it's a parabola. Now, if we add 2 to x, so this time we're not adding 2 to the entire function x squared. We're adding 2 only to x, not to x squared. And or subtract 2 from x. And let's see how the graph changes. And notice that in order to get 0, we have to we want to get a y equal to 0, we have to make your x -2. Because if x is -2 plus 2, that gives us 0. 0 squared will give us a 0. So for the same y value, and we actually have to subtract the 2 from this 0. So in order to get the same y value. So that tells us at -2, when x equals -2, we will get a same y value 0. And similarly, in order to get 1, we have to make x -1, because -1 plus 2 is positive 1. 1 squared will give us 1. So that's going to shift. We have to move this point to the left on 2 units. All right. So by doing that, every point is shifted to the left 2 units. And similarly, if we want to get 0 for y, we have to make this x equal to 2, because 2 minus 2 is 0, and 0 squared is 0. So again, in order to get y equal to 2, x has to be moved to 2. and every point will be shifted to the right.